So a complex number is any number that's expressed in a plus bi form. Now what that's saying is that a complex number is not an imaginary number, it's an imaginary number in which you've already performed some substitution, and it's expressed as a number plus an I to the first power term. So here are some examples of complex numbers. This is a complex number, 4 plus 3i. This is a complex number, 8 minus 6i. And if we wanted to add these two things, we just treat them just like we would any other radical or any other x term. So let's distribute the 1 in front of the parentheses here and express this as 4 plus 3i plus 8 minus 6i. It may just look like I dropped the parentheses, but really what I did, I distributed a positive 1, yielding the same result. So now we have 4 plus 8, which is 12, and 3 minus 6i, which is negative 3i. Notice how I express my result in a plus bi form, which means number, then I term. If we wanted to subtract complex numbers, here's a 1 in front of here and a negative 1 in front of here. Let's distribute the positive 1, giving me 6 minus 3i. Let's distribute the negative 1, which gives me negative 2 minus 2i. And now we can combine like terms. 6 minus 2 is 4. Negative 3i minus 2i is negative 5i. So that's adding and subtracting complex numbers. Really nothing new here because we know how to add and subtract x terms. We know how to add and subtract radicals. And that's pretty much all we're doing because remember, I is a radical term. So you're treating it just like you would any other radical term. Some difficulty may come when you decide to multiply or divide radicals, when you have to encounter multiplication and division. So multiplying, we're going to treat it just like this would be any other binomial times a binomial, and we're going to FOIL it. 2 times 3 is 6. 2 times negative I is negative 2i. 2i times 3 is 6i. And 2i times negative I is negative 2i squared. So we have some like terms combined here. 6 plus 4i minus 2i squared. Now, this isn't a complex number yet, because we can still substitute for I squared. And I know that I squared is negative 1, so I'll say 6 plus 4i minus 2 times negative 1, which is 6 plus 4i plus 2, and now I can combine like terms, 8 plus 4i. So the key here was it's not a complex number until it's in simplest a plus bi form, so you may have to do some substitutions. Dividing is probably the most challenging operation on complex numbers. And in order to introduce the method on how to divide complex numbers, let's just think about what an I stands for. And I was a radical. So really, we have a radical in the denominator here. How do we treat that? If we had a radical in the denominator, how do we get rid of it? We multiplied by the conjugate of the denominator. So, let's take 1 plus I over 3 minus I and multiply both the numerator and the denominator by 3 plus I. Why? Because that's the conjugate of the denominator. Same terms, 3i, opposite sign in the middle, negative, positive. But this is an expression, so we have to multiply by a form of 1. So let's FOIL the numerator. 1 times 3 is 3. 1 times I is I. I times 3, 3i, and I times I squared. That's just the numerator. Now let's FOIL the denominator. 3 times 3 is 9. 3 times I is 3i. Negative I times 3, negative 3i. And then negative I times positive I is negative I squared. So we'll have to combine like terms, and we'll substitute negative 1 for I squared. I'm going to do that within the same step. 3 plus 4i plus negative 1 over, well, the outer and inner cancel, 9 minus negative 1. Let's clean this up. 3 minus 1 is 2 plus 4i over 10. Negative, negative, positive. The only thing we can do here, we can divide each term by 2. So this is 1 plus 2i over 5. One last thing. and that is searching for the multiplicative reciprocal. What is the multiplicative inverse of 3 plus I? Well, the multiplicative inverse is simply the reciprocal. So the multiplicative inverse is 1 over 3 plus I. So the multiplicative inverse is 1 over 3 plus I. The problem here, still have to simplify it. Not allowed to have a radical in the denominator. So let's multiply by the conjugate. 1 times 3 minus I is 3 minus I. And now let's FOIL the denominator. 3 times 3 is 9. Negative 3I, positive 3I, and minus I squared. So the numerator, 3 minus I, over, negative and positive cancel, 9 minus I squared, which is negative 1. So you end up with 3 minus I over 10, which cannot be simplified. So this is the multiplicative inverse of 3 plus I. Which means if I had multiplied 3 plus I and 3 minus I over 10, I should get 1. Let's check. 3 plus I times 3, what do we have? 3 minus I over 10. So the denominator here is 1, so my denominator will be 10, and I will just have to FOIL together 3 plus I and 3 minus I. 3 times 3 is 9, minus 3I, plus 3I, minus I squared. These cancel. I squared is negative 1, and 9 minus negative 1 is 10. 10 over 10 is 1. Therefore, we found the multiplicative inverse correctly.